Hi all. Today we are discussing about the Pike operating system. So these are all the contents we are going through today. The introduction of Pike OS, the history and evolution, goals and purposes of Pike OS, standards, architecture, subcomponents, complexity and cost of implementation, what are the pros and cons of Pike OS, and organization engaged, and some organizations, competitions, what is the future trend of Pike OS. So, so yeah. So what exactly is Pike OS? It's a real-time operating system developed by a company called Sega, which is specialized in making embedded software solutions for safety and security industries like automotive, aerospace, railway, industrial automation, and medical devices. So it combines it combines IDE based IDE based on Eclipse with virtualization. So PikeOS was first published in 2005 as a commercial device of L4 microkernel. Then the versions were released by 3.4, 3.5, and the latest version is 5.0. These versions were released by improving and optimizing to meet the needs of industry requirements like the safety protocols and also for medical devices. So there was an evolution, they made an improvements so that it can meet the industry needs. So, comes to goals and purposes of Pike OS. The aim of Pike OS is to support industries where safety is the key component. Industries like aerospace, defense, automotive, railways, and industrial automation. So security is the key for Pike OS development. It has multi layers of architecture that can serve both as real-time operating system and also type 1 hypervisor. So that was the main advantage of Pike OS. It also enables concurrent execution of multiple operating systems in a single hardware platform. So it has some security standards and safety standards, while and also some certifications they have claimed to provide secure and um, safety operating system. So it has safety standards like DO 178C, ISO 26262, IEC 61508. These are all the standards so that the system will be protected from cyber threats or cyber attacks. And also ROTS standards it is compatible in portable OS interface and Organic 653, ensuring it will run the OS in this particular software interfaces. So this is the architecture block diagram of Pike OS. It has a microkernel architecture, which will um, which makes it efficient for the system management. So, and let me show you something in this diagram. It has partitions within the system, so that um, it can run multiple OSs in a single hardware device. So these partitions, each application is virtualized to run in see these are the partitions of it can run Android in this application. It can run um, some other operating system, and these are all some guest OS. See, you can see that Linux, Android, any operating system can be run in parallel in a single hardware system. That's what the advantage of Pike OS, where it can run multiple operating systems in a single hardware platform. So these are the subcomponents, as I have explained. Like it has microkernel architecture, which is used for efficient system management and effective operations, and hypervisor, which will run multiple guest operating systems and in a single hardware platform, and partitions, as I said, as I have explained in the previous slide, saying that it has partitions. See, Linux is an operating system, Windows, Pisos and AR and Pike Native. These are all multiple operating systems that can fit inside the Pike OS hardware. So uh, and also it will maintain some security standards while running multiple operating systems. So this a Pike OS with S4C FPGA board. This is some combination. Citrus has combined with OpenSBI to build a board, so that they can. These are some of the applications that has been done using PikeOS. So this is the firmware where it launches the application. So heart is 0, and HSS firmware, OpenSBI, U-boot, both will be running simultaneously, and Pike OS will be combined with with this board, so that it can provide some effective performance for that Polar Fire S4C board. Um, So that's what the interaction, that's what the application of Pico is with SOC. And one more thing is that um, Pike OS has been used in space operations by European Space Agency to create time and space partitioning solutions for for their spacecraft, IMA-4 space. So this project has used Pike OS in their project um, to run Leon platform, and used integrator modular avocations IME system that will streamline electronics in future space applications. This Pike OS was the main key component of their system which was sent to space explorations too. So this was the architecture diagram of using the Pike OS in their IMA-4 space station. So they were running multiple OSs, some multiple codes in a single hardware device. So uh, that main application of Pike OS that has been used in this IMA for space. project. And when it comes to complexity and cost implementation, Pike OS is highly configurable because it needs, as it has multiple um, partitions that needs to be configured. So it needs some developers to get getting some knowledge with that with the device so that they can meet, and also they need to do some certifications provided by CISOs, uh, the company which has founded Pike OS. Then they will provide some certifications. They need to complete those certifications to um, configure this Pike OS application. And also this cost factors like licensing fee to take the Pike OS, and development tools supporting services from the CISOs. They provide these all things at some cost. So it is a bit of costly, but very advantageous operating system that can run multiple um, softwares in a single hardware platform. So, um, when it comes to advantages and disadvantages, it is predictable, secure, secure application. Obviously, that's the main thing for Pike OS, and it is configurable. Like we need to configure it so that it can run multiple operating systems, and it is certified. Like um, it has some safety standards, and also RTOS standards, like a real-time operating system standards. And it also has virtualization where it runs uses virtualization to run multiple OSs. But when it comes to disadvantages, it is bit of complex and costly to implement, and it requires some learning about the Pike OS before they start working on it, and vendor dependency. Like they need to depend on um, the CISO's company to provide some support if there are any concerns about the operating system. So these are all the disadvantages and advantages of Pike OS. So this organizations that are engaged, like the industries which use Pike OS or aerospace, like I have said, some applications um, that have used IMA4, that has used Pike OS in their systems in the spacecraft, defense, automotive, industrial automation, and some medical devices. And also in the Pike OS website, they have also mentioned uh, um, this Pike OS has been used in railways too. So these are all the embedded systems, like the safety and security embedded systems. So, and competition to Pike OS or some um, so there are many industries which are producing some embedded software systems to meet their security needs, like VX Works by Wind River, and Green Hill Software Solutions, QNX Softwares, Linux Software. So these are all the companies which are also providing RTOS and hypervisor solutions. They are competition to Pike OS, but Pike meets all the security standards, and also it is bit of complex and cost need, but it is a very useful operating systems that can operate multiple operating systems in a single device. And when it comes to future trend, Like I would also suggest to Pike to minimize the cost of licensing or the certifications so that it can achieve some great standards over the coming years. And also they can implement something like a artificial intelligence and machine learnings. As this is an AI era, they need to concur with AI and machine learning so that they can enhance some more software and hardware ecosystems. And so let's come to the conclusion. In conclusion, we say ROTS is a safety and security embedded system which is used in various industries, and it uses hypervisor partitioning and microkernel architecture, and also um, visual virtualization to run multiple operating system in a single hardware device. And the main applications were aerospace industries, railways, and medical industries, automotive industries. These are all the applications these are all the industries which were using Pike OS to meet their security and safety standards. So that's it all about this Pike OS. Thank you for listening.